Hi everyone, welcome to another video. In this video we are doing the final little section of our exponential functions part of this whole series, and in this video we want to now look at solving simultaneous equations, or in other words finding the intersection of two graphs. And now we are looking at using what we know about graphing exponential functions in order to find solutions to this simultaneous equation, or finding in this first example, the intersection point of the graphs y equals to 2x and y equals to 8. Now, we've looked at solving exponential equations in a previous series, but that took a more algebraic approach to doing this. We can also do this graphically, graphically, by sketching these out and then looking at the points where these intersect. So what I'm going to do is I'm going to look at sketching both of these graphs. Now, my first one here, we know that this is an exponential, and we can quickly do a table of values, but we've looked at this one at length before. So let's just go from -1 up to +2. And I'm just popping these values in right off the bat. Just have a go if you want at substituting each of these x values into here, and you should get these bottom values for the y. But I'm just doing this quickly because we've sort of done this at length before. So if I go about sketching this, I have an x value here, I have a y axis, and I'm going to first draw my exponential curve, y equals 2 to the power of x. So that's going to look something like this, y equals 2 to the power of x. And we just want to label in a couple of values here. So I have my intercept here at y equals 1, and a couple of other things I know is that when x equals 1, y equals 2, 2. So this point is 1, 2. When x equals 2, 2, y equals to 4. So the point is going to be 2, 4. And way up here, when x equals to 3, what's y going to equal to? Well, y is going to equal to 2 to the power of 3, which is 8. So we have the point 3, 8 here. So this graph, this exponential, we want to see when it intersects with this graph y equals 8. So 8 units up is going to be roughly, let's say here. And basically we want to just draw this in, and we want to see exactly when our graph intersects with this. Now this isn't going to be to scale, and it's going to be a little bit dodgy, as you can see I've drawn here, but I can pretty much clearly see that when y equals to 8, this line, it has a y value of 8, and it's going to meet the other graph of y equals 2 to the power of x at the point where x equals 3, because when x equals 3, I have a y value of 8. So graphically, I have shown the point where these two are going to meet, my line of y equals to 8 and y equals to 2 to the power of x. Now, for that point, that's just going to be the x value of 3. And now you could have done this as well, solving the exponential equation. You can pause this video and have a go at that on your own. But now that we have this x value of 3, so the solution to this was 2 to the power of x equals to 8. Now here, the solution is that x is going to equal 3, like this guy up here. An x value of 3 is a solution to these two. And now we just want to substitute in the y value in order to find the y coordinate of this point of intersection up here. Now we can do this in two ways. We can substitute it into equation 1. This is going to be that my y value here equals 2 to the power of 3, which is going to be 8, as shown on this graph. Also, we can substitute it into here, and this thing just tells us that the y value is always going to be 8. So this is actually kind of substituting it into here. There's no actual substitution to be done. We just know that the point where this intersects, it's always going to be at y equals to 8 for this particular graph. So the point of intersection is going to be, let's write that as POI, is going to be an x coordinate of 3 and a y coordinate of 8. And I get that by solving this exponential equation. I can do it that way, but we can also now do this graphically now that we know how to draw these exponential curves. I'm pretty much just matching this curve with my line of y equals 8 and seeing where these two meet. Let's look at one more example to finish up here. We have this first function of y equals negative 3 to the power of x. Now, if we put on our exponential transformation hats using the skills we learned in the last video, this particular negative in front here, remember that is a reflection. So this is going to get vertically reflected. All the values that would have typically been positive y values, if we had y equals 3 to the power of x, those become negative by virtue of this minus sign. But let's just confirm that by just substituting in some values into our table of values again, see what we get. Now putting in x equals negative 1 here, that gives us minus a third. Putting in 0 gives me 1. This gives me minus 3 and minus 9. So I'm going to sketch this particular function. I have my y-axis, I have my x-axis. I've drawn this in a weird wonky way, it may look like, but there's a reason I've drawn the axes in this way, and we can see why when I end up actually drawing in these points. So I have a couple of values of x that I'm labeling over here, and at x equals negative 1, I'm at a third in the y, and here's my 1. So this is going to look sort of like this on this particular side. When x is negative 1, y is negative a third. That kind of looks about right on this point that I've drawn about here. And then when x is 0, y equals to 1. So we have our intercept here. And then this is going to keep going like so. Let's actually draw this in a slightly different way. It's going to look sort of like this, because when x equals to 1, y equals to about negative 3, and when x equals to minus 2, all the way down here we get, if I extend my graph a bit more, obviously this is going to look a bit better to scale. I'm just doing these as like an approximation right now, but my y is going to equal to negative 9. Okay, so we have our graph that we've drawn of y equals minus 3 to the power of x. This is just a graph, an exponential graph with a base of 3, but it is negative. So you can see it's in the negative y-axis. It's reflected down here. Okay, so now that I've drawn that, I want to draw in my second graph here, y equals to negative 9. So extending this y-axis down to here, I have the graph of y equals negative 9. That is a horizontal line. So I'm going to draw that through here. and it goes on both sides. This is my graph of y equals -9, and this particular point is where it intersects my exponential graph here. And that point is basically, we just need to read off where this lines up with the x, where this lines up with the y. So I can see this is at 2 in the x. So that's going to be my x value for the point of intersection, and I have -9 in the y. So I have that there. This is my point of intersection of these two graphs. My graph of y equals to -9 and y equals to -3 to the power of x. This sort of upside down exponential here. But we can solve these types of equations and these simultaneous equations with now two graphs by just sketching out a nice to scale graph of my exponential, and then also sketching out my line and seeing where exactly these two meet, and those coordinates become our point of intersection. That brings us to the end of today's video and to the end of exponential functions. And for the remainder of this series, we will be looking at some new other types of functions as well. Thank you so much for joining me, and I'll see you next time.